All right, this is the last video for 3.1. So we're going to model with mathematics. A skydiver drops out of an airplane that is flying at an altitude of 4,624 feet. Use the formula h equals negative 16t squared plus h naught. That's what that h to the subscript 0 means. To write an equation that gives the skydiver's height in feet during a free fall, which is t seconds, after the skydiver drops out of the airplane. Now I want you to remember this equation right here. That h naught just means the initial height. It's where you're starting from when you start an equation, or when you start your parabola, okay? So it's basically your y-intercept, okay? And this is what you will use for any kind of falling problem, okay? That's like gravity is being enforced on something, something's falling to the ground. That's what you're going to start with, okay? So that's just a hint when you get to the practice there. I wanted to point that out. Okay, but this says the airplane is at an altitude of 4,624 feet. And it wants us to write the equation that gives that height during the free fall, okay? So we need the equation of our parabola. Well, our height is going to equal a negative 16t squared, okay? So that's however long they're in the air, but my initial height is 4,624, okay? So that's the equation. Then it wants to know, is it possible for a skydiver to wait 16 seconds before pulling the parachute cord? So if we're in this airplane, I'm not even going to try to, well, maybe I'll try. I'm drawing an airplane. Woo. Okay, that's what that is. It's got another wing. It's got a tail. I don't know. Looks like a fish or a torpedo. Whatever. It's an airplane. And it's cruising along here at 4,624 feet. And someone's going to jump out of this airplane and they're going to fall to the ground. And hopefully land because they had a parachute. I don't know. Okay. Well, they're going to pull the parachute at some point. Okay. But we want to know, is it possible for them to wait 18 seconds to pull it? So we really want that 18 seconds to be somewhere here, because if it's somewhere here or below, they went splat, which is a very horrible image, and I'm sorry. So we really want to know when is it going to hit the ground if they haven't pulled the parachute, okay? So I want that x-intercept. So I'm going to find the x-intercept of this equation, which means my height here, if that's 4,624, this is when my height is 0. So I'm going to plug in 0 for h, and I'm going to solve. So negative 16t squared plus 4,624. Actually, there's two ways to do this, but we're going to start with this way, okay? I need to subtract the 4,624 to both sides. So I get negative 4,624 is going to equal a negative 16t squared. Divide both sides by negative 16. All right, so we're going to get, I'm just switching my sides here. I'm going to get that t squared equals 289. Square root both sides. So t will equal the positive and negative square root of 289, which is the positive and negative of 17. So I have a positive 17 and a negative 17. But since we are talking distance, okay, distance is never negative. Okay, since we're in the right quadrant quadrant 1 of our coordinate plane, we need x to be positive. We didn't move this direction, okay, when we graph these, okay? So it was 17 seconds, a positive 17 seconds amount of time before someone would hit the ground if they did not pull their parachute cord. So if they waited 18 seconds, they waited too long, okay? So that's one way to prove our answer. Another way you could have done this was taking your equation and plugging in 18 seconds. So I want to know the height after the time is 18 seconds. Okay. All right, so now I can just plug all of this in my calculator and I see what I get. And I get that h would actually be negative 560. So my height is negative, which meant I went farther than the ground, so that would not work. So you could do this either way, okay? So now that you've done this problem, go to practice and do number 59. Then you should be complete with your practice, submit it on Big Ideas, and then submit it on Canvas. Submit your screenshot of your score onto Canvas.